Okay, where are we? So we discussed so far about the file system, how actually the Hadoop came. Okay, can anyone tell me who was the inventor of the Hadoop? What was the name? Yes, you're saying something, Thiru?
I cannot say. Well then,
Sorry, I didn't get it. The name? Okay, the name of the person is duck cutting, and where actually it was developed or invented, in which company or the lab?
Yahoo.
Correct, Yahoo. Okay. Can you please tell me what is that reference they had taken to create the SDFS?
It's something like Google Paper.
Google white paper documentation, that is GFS. Yes, okay. So I think we are quite clear on that particular part. Okay. And one last question, what is the default block size we are using in Hadoop?
128 MB.
Yes, 128 MB was derived on 2.x and 1.x it is actually 64 MB.
54 MB.
Right. Okay, let's talk about the architecture side. Okay, so we discussed, I guess, last session that the two major pillar of this particular topic, or you can say the Hadoop inside of the Hadoop. The first one is the storage, and the second one is the processing. Now, as you can see here, for the storage, we have HDFS. Okay, and that HDFS is actually for Hadoop distributed storage system. Okay, and the another hand, we have a MapReduce that is also a distributed data processing. So as you can see here, I have just segregated into the two sets. The first set is actually for master, and the second one is actually for slaves. So what is that masters actually? So as you can see here, I had highlighted three of them. One is the job tracker, name node, and the secondary name node. And if you notice here, for the name node, I have given a dotted line to a data node. And from the job tracker, I have given a dotted line to the task tracker, which means that the name node can interact with the data node and the job tracker can interact with the task tracker. Okay, let's understand one by one. So what is that name node actually? The name node, as the name said, okay, that is actually name, and node is nothing but the server. Wherever you can find in this particular topic that node, that is nothing but a server, or you can say the particular endpoint where we are keeping our data. Okay. The name node is actually nothing but where it is actually maintaining all the metadata information and the FS image. What is that metadata and the FS image is actually, metadata is nothing but the information about the data. Okay, and FS image is nothing but file system image. It's nothing but the copy of the data, what is that actually inside of my server. Okay, I'll tell you in detail about the metadata. Let's suppose you have a one book. Okay, you have noticed that every book have an index copy, or you can say the index pages are there. So what is that meaning of this index? If you want to go to the chapter number 13, you can directly go check into the index where is the 13th chapter start, and you can directly go to that particular chapter itself. Clear? So that is the same way for the data also. We have a metadata information. So the name would maintain these information. It maintains the metadata and the FS image, all the cluster. It's mean if you see this particular one, it will be like the server. This is our server room. Have you ever seen these kind of data center, guys? There are the number of servers, there are the number of indicators are showing then all. So these are actually racks. So it's look like this one only. Okay. Here these slots, okay, these like 1, 2, 3, these all are servers actually. Okay. So in this particular one, you can see here, it is actually connected to a one bunch of wire, and that is called switches, and it is connected to a final or one master server. It could be any of them. Okay, they decide how actually they need to keep it. Okay, so this kind of data center, it is actually called cluster also. Okay, cluster is nothing but bunch of the servers are connected together, okay, with the help of the switches. Switches is nothing but like extension cord we are using, right? We have one power cable, and I just want to split the number of, I have a charger for laptop, I have a charger for mobile, and a charger for some router or something else. Okay, so that actually I have a one port only, and I just want to keep it together. So that extension board is nothing but like switches. So we can connect to that particular point, and we can connect to the final server, and that is nothing but the main switchboard. Clear? Now I'll show you something. I don't think so. I kept here. Okay. Uh, So the name node, what actually it will do? Let's suppose if I want to store any of the files. Okay, so the name node keep those informations. Okay, where actually which files are there. Okay, so these kind of maintenance need to be done by the name node. So let's suppose I'll take a one example. Okay, I have a one warehouse. Okay, and that warehouse have a hundred or thousands of rooms are there. Okay, in this room I'm keeping all these storage level things. Like suppose somebody came and want to store their particular boxes or something, and just why actually I'm giving this lemon example, so that it will be very clear what we are what actually I'm explaining to you. Okay, so let's suppose Tiru is came and come with the four boxes, and he was saying that I just want to store into your warehouse. Okay, so what will happen, I'll keep into a some particular room, and I did not maintain any directory or any like metadata information or index or diary for that particular, or you can say the register book. Okay, after a month, maybe you're coming back, okay, and asking for that particular data or information, but I really don't have any maintained book or register to check those particular data. So it will be very difficult for me to find that particular box. I don't have the labeling or something, then it will be very difficult. So the name node, what actually, or the systematic way, if you notice that if you are going to any of the warehouse, they are maintaining one register. So whenever any new kind of things are coming, or goods, or you can say the boxes, the same way in the name node, if any of the new datas are coming, they have a entry inside of the name node. So what is that data? File name, what is that size of it, and how many blocks we are creating for that particular data set. So these information will keep into name node. So this is what actually we are keeping. And one more thing, name node is not keeping the data. They are just keeping the metadata and the FS image. Now the questions arise where actually the data resides. So the data reside in data nodes. As I mentioned that, like suppose if we have a warehouse, in a warehouse, how actually it is storing into a rooms. That is nothing but our data node. The data node is actually designed to keep only the data, right? It is just like a dumping zone. We can dump anything, whatever we have, as the expectation from the name node on the client side. Okay. Now the next thing, what will happen? Let's suppose we are keeping this information in some of the places. That is nothing but the name node. And somehow something happened to that particular server. And tomorrow, if you are coming and the name node itself is down, so will you able to access those data? That is not really possible because the name node itself, or you can say the master server itself, keeping all the information where actually which data are residing. Then it will be very difficult for that. So what actually they had smartly designed, they had designed one secondary name node. This is the secondary name node. Sorry. What actually secondary name node will do? Secondary name node work is whatever we are keeping into our name node. Okay, they will take that particular backup into their own system. And in case of name node get down, then immediately secondary name node provide that particular file to the name node. Clear? And when actually it has happened? So every 60 minutes, name node got a trigger from secondary name node that it's been a long time and I need the file of metadata or information, those things. So what we'll do, name node will provide that particular details and secondary name node keep updated that particular. It is like in sync, but every hourly wise. Understood? Guys, clear?
The in secondary name node, is it like a backup?
Yes, it is actually backup of metadata and the FS image. Okay, just to ensure, okay. It's
Okay.
not about the data. We'll come later about the data. Okay. So now why actually this information is required? Okay. I explained, right? Let's suppose if you want to find it, let's suppose Nikita came and come with the 10 boxes. And I had just noted down this particular one in register book. I keep this particular item in room number 23. Okay. And I have given the date, what is that item, and each and everything I just maintain it. Okay. And later, Nikita came back with this particular one. This is my item and this is my name. So I will going to find it into register only. Right. So if this register is self corrupted or maybe it's lost, then it is possible I can give you the data. That is not really possible, right? So this is what actually the name node and secondary name node work. Secondary name node is a backup of name node only. Understood? And these keep a backup of our metadata and the FS image. Clear? Clear, Nikita?
So FS image means what?
FS image, I'll tell you. FS image is nothing but file system image. I'll tell you in detail, you can understand this one. Do you have noticed like, or have you ever seen, okay, that, I can explain you this FS image. Um, Yeah, like suppose you have noticed, okay, in the earlier phase of Windows, okay, the companies are providing one DVD writer, or you can say DVD CD of the OS. Do you remember that when the Windows 7 started or Windows XP, they provided one CD. Or nowadays also you have noticed that we have installation CDs are there. Okay, with the help of that particular image, that particular file, you can create a operating system, and that is actually created by the organization or the company, and that can be loaded into number of systems. So that FS image is nothing but the file system, whatever we have now, the size where actually these files are there. Let's suppose ABC file. ABC file is 3 GB. Okay, and how many blocks are there where actually it is reciting. Okay, these kind of information it will be inside of it. It is just a linkage of my original data. Understood? With the help of that, we can access to the final data. Clear,
Sir.
Nikita? Okay.
Yes.
Now, the next
Sir,
thing about
Sir, this secondary node created runtimely created, or you have any scheduler?
It is actually runtime only. It is on sync, as I mentioned, but it is actually 1 hour. Every 1 hour they will keep a backup. And this is 1.x, okay. In 2.x, there is a upgraded version of it. So what is that actually? We'll see later when we go to the 2.x. Okay. So first understand this one. Now the next questions here. Will the secondary name node act like a name node or take a part of it if the name node is down? So the answer is no. What actually the secondary name node will do, it will keep only the information. And if the name node get down, the entire cluster will be halted. It's mean none of the process will going to perform on that particular point of time until unless there is a no name node get active. So what is the task for the secondary name node? The secondary name node task is whenever a new name node came into the system, these this secondary name node keep those information, provide those information to a new name node, and then the work get started. Clear? So if this second name node is down, secondary name node will not take a responsibility of the name node. It will act as a backup node only. Okay. Now the next thing is that let's suppose my cluster got started by some reason. So what actually they had designed in this secondary name node, they will act as whenever a name node is starting, the secondary name node seems like okay, he think like or he understand that okay, this particular node is actually a newer node. So what actually they will do? They will check the metadata and the FS image from the name node to a secondary name node. And that is nothing but the syncing of those particular information. If both are on sync or if it is not in sync, so they will copy those particular information from the secondary name node to the name node. So with the help of that particular thing, we'll able to provide the syncing message or the data. And this particular process, when they are syncing together, that is called safe mode. And that duration max to max is 15 seconds, not more than that. Sometime it get extended, maybe the network issue or something, but max to max it will take safe mode is 15 seconds only. And the another thing is that will it possible if I know the informations are actually in sync, I just want to stop it forcefully. Yes, that is actually possible. You can forcefully trigger it and make the safe mode disable, or you can say stop. The questions arise, is it possible I can activate the safe mode? Yes, that is also possible. So there is a syntax, or you can say the command, which is used to start and stop also for the safe mode. That we'll see in the practical way. Clear? Guys?
Hello, sir. Hello,
Yes. Yes, tell me.
sir. When name node is crashed, so
Mhm.
secondary will back immediately, or it will take time to back up.
Okay. So let's suppose name node is got crashed. So what will
Yes,
happen? So the admin people will get the trigger for that the name node is got crashed. And internally
yes,
what will happen? The cluster will halt it. It won't
yes,
perform any of the certain tasks. Okay. So first we'll understand about the node wise and then come to this particular point. So what will happen? Admin will come to know, okay, this particular node is got crashed. So what we need to do? We need to assign a new node. So internally, the admin team has assigned a new IP address for the name node, and this is our new name node. And start the batch for that. So it will activate as a name node. So secondary name node will come, okay, this is our new name node. Need to check the metadata information and the FS image. They will check that, okay, what is that information? They have a zero metadata and zero FS image. So it will start copying those information which is actually inside of the secondary name node, and it make this new node as a active name node like a earlier. Understood?
Yes, sir.
Once the sync is completed, the secondary name node trigger and safe mode will off, and then it will start the further process. Clear? Now the
Yes,
next
sir.
thing. Now the next thing. Let's suppose this question is arise. Let's suppose there is a copy is happening, or maybe data is getting storing into our system, that is a 50 GB or something. Okay, maybe anything. It could be anything. Let's understand with the percentage wise. So either it could be a 5% or 10% or 15%. Okay, it got copied, and in between of that, our system or maybe the name node got crashed. Then what will happen? It in this particular scenario, what will happen? The entire process will get stopped. Okay, and it will start when a new name node got assigned. So once a new name node got assigned, the task will automatically rerun and start from that particular point only. It is not running because the reason is until unless there is a no name node, the data node will not provide any information and it won't work because name node is the main node for all the data nodes. Data nodes are like blind only. Whatever the work you are giving to them, they are going to perform, and it will only follow the order from the name nodes. So in this particular scenario, if name node is not responding, the entire cluster will not work.
So what is data node?
Data node, we are coming on that particular one. Okay, so clear so far?
Yes, sir.
Okay, what is the data node actually? So as I mentioned, okay, let's suppose I have a 1 GB of data. Okay, so let's suppose Nikita is a one data node. Okay, and Thiru is the master node. Okay, Thiru is going to maintain the information inside of it, and the data will going to reside inside of the Nikita server. Okay, and Nikita is a data node. Understood? All the data is going to reside or is going to dump into the data node itself. It is not going to reside into the name node. Name node just keep the informations, and always this node is active for storing the metadata and the FS image. And the data node, as the node said or the name said, data node, the node which store data, or you can say the server which store the data. Clear? Let's understand this diagram. As I mentioned to you that there are the number of switches are there which is connected together. Okay, and all the data node, name node, all are connected to this particular one. If you notice that I shows you one rack, these are the racks only. Each slabs, or you can see this particular is nothing but our server. It could be anything or it could be anywhere. It is possible maybe this particular one will be in this side and this one will be in this side and like this. But the thing is, if you notice here, all of them they had keep it into a separate rack. In case if this particular rack will get down, they will get the alert and they can maintain it. It should not be all the major, or you can say the master server get down at the same point of time. What is that client node actually? Generally, client node, or you can say the edge node, it is provided to all the developers. Okay, admin have the access to all the nodes, data node as well, job tracker, name node, and secondary name node. But for a developer and the QA engineer and the DevOps and the BA people, most of the cases, the bigger company or bigger MNCs provide the client node access, or either you can say the edge node. When you join any of the company, they will say that I need a edge node access, I need the client node access, Okay, so these kind of words you will heard when you join any of the organization. What is a client node actually? This node actually is connected to the our cluster, and if you perform any of the tasks, it will get triggered and directly connect to the name node, and name node will perform those particular operation whichever it is required. And the client is not really required to connect directly to the data node. It is not required to connect secondary name node or job tracker. It is actually designed to directly interact with the name node only. And name node is nothing but our entire cluster informations. Understood?
One thing here is like whether the client node will connect directly to the data node too, or only to the name node.
Through the name node only. There is a no use to directly connect to the
Directly
data
connect
node,
to the
because
data node.
yes, the data node will never provide the information until unless the name node is not active. And the another thing, okay, will come on the next slide or in the practical, I'll show you. Data node only understand the block level thing, okay, and the name node only understand the file level as well as the block level things. What is that meaning of it? Okay, I'll show you something.
What is name node is like master server.
Yes, master server.
Okay. If it fails, then
Yeah.
everything.
Mhm. If
Uh,
it is failed, in case of name node is got failed, my entire cluster will be halted. Halted is
okay.
nothing but it will be pause mode. Whatever the operation was running, that will be halted, and it will get active once my name node get activated. Understood? So whatever the
Okay.
process is running, let's suppose we are triggering any of the job and it is got completed at 30%, 20% or 40%, it will get a stop over there. Okay, and once the name node will respond, then again it will start from that particular point of time. Why actually it is got halted for a minute of point also, that we'll see in the next slide. Okay, so I'll give you the another things. Okay, what actually I was explaining, somebody has asked me, I forgot that. Who asked me, what is that question? I forgot that. Yeah, so
Something.
node and secondary name, what is that metadata information and all those things. Okay, see, this is the file name. Okay, and let's suppose this file is actually 200 MB. Again, I'm taking this example so it is easy to understand for you people. So this is the block, and the block name is something like this. Sorry. These blocks names are unique. Okay, it is every time, it never be like it is a sequentially, okay, like roll number wise, or you can say the tracking ID wise, it will be unique. Okay, sequentially it will come. So let's suppose it is 1, then it is 2 and 3, 4, like this one. So all are unique among them. Okay, so now if you are going to interact with the data node, okay, someone asked me this question, okay, that I just want, is it possible the client can directly interact with the data node? Then what happened? You know the file name, right? Who asked me this question?
Yeah, Ravi came.
Yeah, Ravi. See, the Ravi, you told me that is it possible the client can directly interact to the blog? Sorry, the data node. Okay. What is your file name? Your file name is ABC. So you are trying to connect to the data node and asking that data node, could you please tell me where is my ABC file? But he doesn't know what is that ABC. They only understand with this particular one, the block ID, and you don't know the block ID. This will be maintained by the name node only. You will never know what is that block ID and what is your block or how many block is got splitted. And each and everything, it is actually maintained by the name node only. That is the one thing. The second thing is that somehow you come to know, okay, data node 23 is the node where you had kept your data, or the name node has kept over there. But you are not really sure that how you are going to connect, because the connection or the architecture, it is designed like it can only be accessible by the name node only. You cannot access directly to that particular file. Understood?
Yeah, whatever I'm doing in the Hadoop, it will, I mean, the data will goes to the name node only. I mean, it has to go to the name node only. Sorry, yeah,
Yeah,
name node.
has to go through the name node, which means it is like, see that there is actually myth. Okay, number of student understand, and there are the trainer also. I heard they are just miscommunicate to people. Okay, don't go this particular one, and the interviews also they will just trick you. Okay, so it's like they will ask that. Okay, let's suppose I have a data. The data is ABC XYZ or something, and that is a 200 or 1 GB or something data. So it's mean this data will first store in name node, and then only it will go to the data node. So the answer is no. It will directly go to the data node only. Name node only decide which node it is going to be. Okay, it is not actually first it will get stored into the name node, and then name node will move those particular data into data node. That is not the case. It will directly store into the data node only. It just give which data node I need to select. Understood? I have a thousands of nodes are there. It is not just like a 3 node or 4 nodes cluster. If we are talking about the production server or any of the organizations, okay, which actually using the Hadoop, there are the thousands of servers are there. Okay, maybe smaller company or maybe smaller requirement, maybe they have 100 of servers, 100 of data nodes, but actually all the data will going to store into the data node only. It never be going to the name node. Name node only decide which node to be selected. Clear?
Yeah, okay, understood.
Okay, still have doubt, you can ask me, no problem. Thiru, Nikita, Akhilesh.
Sir, if any data we are giving to the node, it will store for, it will go to the name node first. After that, it will go to the data node.
That is what I was saying. Okay, that it is I'll show you something, okay, in the next slide. Then you people can tell me whether it is actually clear or not. Okay, let's come to this particular one. As you can see here, client is interacting with name node, okay, for storing the data. Client is saying that, okay, name node, I just want to store this particular data. Could you please tell me where actually I can store it? So the name node will suggest, okay, you can just go and store this particular data in these nodes. Okay, and this information, which is at 156, it is provided by the name node only, and it is get split into this one. And if you see here, okay, what is that client is nothing but we have a one server. That particular server, from there we are providing the command, you can see, or you can run the programs. Okay, in a short way I can say that it is not actually the client know, it's mean that you don't know where actually you are storing this particular data. It is just interconnected commands are there, which is routed by the name node only, and it is getting stored into data node 1, 5 and 6. Okay, clear? So this is the blocks which is storing into this particular node. Now the questions arise, how the name node come to know that I need to select 156 only. Why we cannot select 1, 2, 3? Why we cannot go to the 5, 6 and 7? Why actually 156 only? That is the one question arise. Okay. Now let's suppose while storing this particular data, now coming to the data loss side. So let's suppose this particular server get down. Now I have left with the B and C block. I am missing with the block A. Is it possible you are able to access the entire data that file name is file.txt? That is not really possible, because you are missing with one of the block, which I told you in the last session. If you miss any of the block, we cannot access the entire set of the data. So in this particular scenario, what actually Hadoop will do, or the name node will do, they will start making the data replications for that one. So what is that replication? Sorry, it's mean every block will be copied 2 more times into different server, and that is also decided by the name node. Okay, you can see here in this particular. So what I said, let's suppose our C block, okay, C that is this particular rack number 9 is get down. What are the blocks got impacted because of it? You can see C and B. It is got impacted because of this one. So now you can see here in the another hand, in the left side and the middle one, that we have a copy of C block also, one of the copy, and we have a copy of B block also, okay, in rack number 1. So with the help of this phenomenon, that they are triggering this one. So how actually this trigger? The name node will provide this trigger, and the data node 1 start copying this B block into the another node. And the same way they are copying for the C block to the another nodes. And this way they will achieve the replications. And this replication is actually 3, and we can vary it. We can increase also, and we can decrease also. The recommended is actually default 3, and as per the company requirement or the person requirement, or you can say the organization requirement, the data privacy wise, they can increase it, or they want to keep it a single one, that is also a possible. You can keep it a single without any backup. If anything got lost, you will never ever get the recover for that particular information or the data. Clear? Clear so far, guys?
Yes, sir.
Okay. Now, how actually the replications happen? That is the one question. The question number 2 is actually how the name node decide which data node I need to select. The question number 3 is how actually name node come to know that particular data node is down. Okay, these questions will get answered in the next slide. Let's take one of the block, so we'll understand the replications also and all the questions. Okay, so let's take the same example, file.txt, and when we are copying the block A. As you can see here, we have now 3 data nodes for one block A copying. Okay, the same way client is interacting to the name node. Okay, don't think about that. Okay, why every time is 156? It's just an example, okay, for your understanding. Okay, so that's why I'm not changing this particular one. The client is actually interacting with the name node. Okay, and client got the details. Okay, I can store it 156 this particular data. Then what will happen? The client will interact to the data node 1, okay, and store the data. Sorry, before of that, so the client will interact to the data node 1 and ask that, okay, data node 1, I'm going to copy the block A into your cluster. Please connect with data node 5 and confirm it. Then we can start the copy. Okay, and it will go to the data node 5, and data node 1 is says that data node 5 just take a confirmation from the data node 6, and we are getting a one file, okay, and which we need to store it. The data node 6 will inform to data node 5 that yes, I am ready, we can start the copy. And data node 5 will inform to the data node 1 that me and data node 6 is ready, we can start the copy. And then data node 1 will interact to the client and say that yes, we all are ready, you can start the copy. If you notice this one, it is actually serially they are going. Now the questions arise, why they are not interacting in a directly? It's like parallelly. So let's suppose the client is interacting to 1, 5, and 6 as the direct point of contact. This means parallelly all of them. Then what will happen? The thing is, let's suppose I have only one block we are going to copy. Just imagine, okay, we have thousands of blocks at the same point of time. It's like a terabyte of the data. So thousands of blocks multiply by 3. That is actually 3000 connections, or you can say the channel need to be established from the client side. So to maintain that 3000 channel for one of the client, it is really difficult to the client. Okay, there will be a more chances that CPU utilization will get higher and this particular server get crashed, and it will end up with the non storageations of the data. Understood? So that is the reason it will go into the sequential way. That is a point number 1. The point number 2 is actually, if you notice, let's suppose if I'm going to store it the data, then what will happen? It will store it into data node 1 first. Once the 100% is got completed, then only it will start copying this particular data into data node 5. Once the data node 5 is got completed 100%, then it will go to the data node 6 to store it. So if we are going into the parallel sequence, or in this particular way, the 100% or maybe 20% got stored in data node 1, and then 10% or maybe in sync, it is storing into the data node 5 also. So it is possible if any of the channel get crashed, it will end up with the half of the data. It means it is 20% here and 15% here, and both are corrupted data. And every time we need to run a cleanup, okay, for these kind of things. So that is the reason the system is designed in such a way that first it will store into 100% into the first node, and then it will go to the rest of the nodes. Now the third reason why actually this sequential way it choose to store the data. Okay, if you notice that you have any external device like a pen drive or DVD or any hard drive, something, and you are copying this particular data into your laptop in maybe C drive, D drive, or anywhere. Okay, it is taking us some time. Okay, maybe 30 second, 20 second or something. It got stored. And if you notice that once it got stored in C drive or maybe D drive, from D drive to inside of the D drive, any other folder, if you are moving or copying that particular data, it is faster than to the external device. Did you notice these things, guys?
Yeah, yes,
Right?
sir.
Right? Why
Yes, yes.
actually? Why actually? Because it is internal part. Okay, it is inside of the system itself. So the same way, once the data get come into our cluster, then it is really faster than to the outside. Understood? So once the data inside in our cluster itself into the same network itself, then it is very faster or very easy to store it into inside of the cluster to any other server, and that is more faster comparatively to the outside. So that's why they are not interacted the client parallelly. They are interacted to this system in such a way. Clear? Clear, guys?
Yeah, yes, sir.
Okay. Now let's come to the next question. The next question is why actually name node has suggested 1, 5, and 6. Okay. The 1, 5, and 6 or any of the one, okay, why actually it is got choose? It is actually dependent on heartbeat request. Okay, it's mean name node have all the nodes, whatever the nodes in the system, it is connected with the syncing message. Okay, it's mean that name node got from the every node that ping message, and that is called heartbeat request, and that is actually duration of 3 seconds. Every 3 seconds, okay, the data node sending a message that yes, I am alive. Okay, and this node also providing I am alive and this like this one, and also the name node will get the information that what system is what process or what operation or what is that work it is doing. So with the help of that, it is very easy for name node which node I can select and which node is actually free or idle right now. Understood? So let's suppose coming to the failure part, that what actually or how actually name node come to know that particular node is got crashed and we need to perform a backup for that. So any of the data node, it's not responding continuously for 3 heartbeat requests. It means the 9 second, for a 9 second, any of the data node miss the message pinging to name node, the name node will assume that particular node is actually dead. So they need to perform the replication process. This is the one. Understood? When actually it will going to perform? When the heartbeat request is not given by any of the data node. So in this particular scenario, name node will trigger that particular process. Now the questions arise, whatever the data inside of the data node, it is actually crashed, how we are going to copy and from where I need to copy. So this is going to copy from the metadata and the file system. So let's suppose the data node C is got crashed. So I know in A also we have a backup for that particular file. So I will going to trigger that particular file from the data node A, okay, sorry, the data node 3 to get the block A for that one, and I will copy that particular information to some other one, and I will check what is my replication factor. So it is actually 3, then I need to maintain that 3 using that particular one. Clear? Now what is that block report? The block report is nothing but the information in between of this particular 10 heartbeat. It is nothing but the 30 second. How much data we store into the system. Okay. And what is that process right now I'm running? This means what is that process it is running into my system. So with the help of that, name node will maintain the metadata information and the file system. And also they will maintain which job I need to assign it to which system. Clear? So that's way they are able to see this particular 156. And there is another point which is actually required to store it. Let's suppose I have a data node 1. Okay, so I trigger one of the job. Okay, I'm going to trigger one of the job. So data node 1 is going to take 3 seconds to store this particular data, and data node 2 is actually going to take 10 seconds to store this particular data, because there is some process is running inside of them. So which data node you are going to choose, guys? Which data node?
Data one.
Obviously the data node 1, right? Because it is taking less time, immediate available. Clear? Clear, guys? The next thing, okay.
Yes.
So now the next thing is actually the nearest one, this logic. What is that? The data node 3 is actually is going to take 2 seconds to store this particular data. But what happened, it is actually on process and it will be get free after 30 seconds only. And this particular node, data node 5, is actually going to take 5 seconds. So it's mean after 5 seconds this particular node is free, but the data node 3 is actually going to take 2 seconds to store this particular data, but it will get free after 30 seconds. It's mean I have to wait 32 seconds to complete my task. To assign this particular task, it will take 30 seconds, and to complete this particular task it will take 32 seconds. And in another hand, if you see, it is taking only 5 seconds to complete my task. So obviously I will going with data node 5. Understood? So this particular way, name node will choose which data node will go for this particular operation. So the phenomenon is say that immediate available and the nearest one on the basis of that. Understood? I'll give you the simple example. you people have used, right, Google Drive, right, for dumping your data. Okay. So what will happen when you are dumping your data? It will go first the data inside of the in India data center of the Google, that is nothing but in the Hyderabad, and that is the first copy it is storing in this particular system. Once it gets stored, the copy of that particular data will go to the maybe California or New York or some other place, and the third copy will go into the some other data center. Why actually they are keeping into the separate data center? Maybe the India data center get crashed, that is the Hyderabad center, then we are accessible this particular data from one of the another server. Understood? And you guys have noticed one thing. Recently, the Instagram, Facebook, WhatsApp, it was not running, right? Do you remember that?
Yes, sir. Yes.
Right? In India, it was not running. And you had noticed that it was not running for a longer time. Okay, it's almost 4 to 6 hours or maybe more than that. Okay, okay, it was actually in the evening, 7:30 or something. And in the morning, when you were checking your your message history or whatever it was on waiting, it came on the morning itself. Okay, if that particular server got crashed, you will never ever get the historical data, whatever the history data, whatever the chats are stored into your system. When you open your chat box, you will not able to see those particular chat messages which was going to send, or maybe it is a history data. How actually it is possible? Because it is stored into some other data center also, so from there only it is retrieving that particular data. So this is what actually, and this is how actually the systems work. So if one of the data center is get down, it will not going to impact to our entire system. Clear? Guys, clear?
Yes, sir.
Okay. So this is how actually the name node will maintain the replications, and this is how actually they are calling that. Okay. Now you understand this particular metadata information, the FS image. So this particular file only get copied to the secondary name node. Okay, and just remember this particular one, because these are the interviews questions, like what is that heartbeat request and what interval it will be sent to the name node. So it is actually 3 seconds, and the 10th heartbeat, every 10th heartbeat is the block report. Clear? Any doubt? Next thing is the reading process. How actually the data is get read from the cluster. Like I have a data that which we store into the system a long back. I need some particular data from the system. So how the client is getting interact with the name node and get this particular data? Do we need to write a program for that one and all those particular things? So we'll see this particular one into our MapReduce concept. So before of that, tomorrow we are going to see the installation part, and then we'll go for the SDFS command, or either we'll go for the practical thing, whatever we discussed here, whatever that data node, storing of the data, what is that block, and how actually the files look alike, and how we are going to identify my files and all those things. We'll see each and everything on tomorrow's session. That is practical part. Clear?
Clear, sir.
Any
So
doubt?
I have just a small doubt. For example, consider I have a file like a 150 MB file. Okay. So just I will submit that 150 MB file to the name node first. So what it will do? It will create the 3 blocks, right? For me, since it is a 150 MB, it will create a 3 blocks: 64 MB file block 1, 64 MB block 2, 64 MB block 3. Consider just those blocks will from the different data nodes, right?
Yeah, in different data nodes.
Yeah.
64, 64. And
Whether the
this will,
block address will, is there any chance that block address is same in that different data nodes, or it is a distinct ones?
no, it is a different one. As we
It
saw
is a,
here, if you remember that I told, right, it is depend on the availability.
I mean,
Understood?
what I'm telling is, yeah, is there any chance that of saving the same block ID in the data node 1 and data node 2? I'm asking.
No, that we cannot fix it. This is actually decided by name node, as I told you. Now, the thing is actually, if you want to fix it into one of the nodes, okay, let's suppose you are using a single node server, that is the data node 1. Okay, there is only one node. Okay, in this particular scenario, what will happen? It will store into data node 1 only, with one copy only. That is the one scenario. Now coming to the another scenario, let's suppose you have a two data node, okay, and this particular node, and you had not created any replication. So your data would be in data node 2 or either in data node 2. But if you have a thousands of data nodes, okay, in this particular scenario, you cannot you can assure that which data node need to be selected. And that is actually for a client level or the user level, it is not actually any problem. Okay, either you are accessing to the data node 8 or data node 10 or something, but the logical way it will, yes, I will provide this particular one. You need to connect with the DURGASOFT team. Okay, they will provide this particular nodes and all. Okay, sorry, one second. What I was saying, that if you want to dedicate any of the data node, that is not really possible in the cluster level. That is the one thing. And the another thing is that the decision, it is actually taken by the name node, and it is done availability. Now coming to the one of the things, let's suppose you are storing, which I told you in the bigger level, that is a Google. So Google is storing that particular data first in India data center. You cannot decide and you cannot keep those particular data into California until unless the name node is not decided to move this particular data into California. Sometime if you noticed, okay, have you ever noticed or not, I'm just telling you, let's suppose you are accessing a YouTube or any of the channels, okay, sometime your internet is working very fine, but the YouTube is actually is buffering. The reason behind, the data center which is residing into your ISP or maybe into your area zone, that is not accessible. Then they are trying to connect with the another server. This is what actually happened. So these kind of thing, it is decided by the name node only. As a user, or you can say as a client, you cannot decide and you cannot bound it to go to that particular node only. Yes, you can decide as a number of speed up, like you look for the 5 nodes to be in case engage in this particular one for the processing side, but not the storage side. Storage is only handled by the name node only. Clear? So the answer is no. We cannot decide or we cannot fix any of the data node while storing our data.
Oh, okay. So, and another question is like where this metadata resides. I mean, in which location this metadata resides.
Yes, good question. The metadata is actually reside in local file system of our server. The server which we are accessing into it, it is assigning. And that server is nothing but the name node server. Inside of the name node of the local system, it is residing. I'll show you those particular paths on tomorrow.
Oh, okay. Yes.
So
And
for
another question is
installation,
like, yeah.
Yeah, go
what
ahead.
is needed
Sorry.
for installation? Should we
Install.
do before?
See, installation I already discussed with DurgaSoft regarding this particular part. So they told me that plugin server I already have, the installed systems I have, and for that one you need a VMware. Okay, so tomorrow I will explain those particular installation thing. You don't have to worry about that. It is just a one VMware. Just remember that VM.
Okay, okay.
or either you can say any virtual box. Okay, you can type it into Google, or either when I'm providing the document over that, you will get the links for that. Okay, everything it is provided to you people. And the setup file, it is actually already in the Google Drive. I will provide the link, you need to download it. For that one, just ensure you have at least 8 GB of RAM in your system. Okay, and
Okay,
those
sir, and another.
yeah, one second. So those people who want to access the latest version, or you can see the Hortonworks, or maybe the the Cloudera, which is actually running into our production servers and all. For that particular scenario, you need at least a 16 GB of RAM. Okay, otherwise the one which I have created, that will be run smoothly and it is performed the same way only. That is no matter on it. Yeah, now you can ask.
Yeah. Another question is like, sir, when if you want to create a folder in the HDFS, whether that folder will be created in all the clusters or only in, I mean, how it will create the folder, sir? I mean, to store the files.
Yes, good question. See, the folders and all those things, it is actually created into a, you can say the metadata wise. Okay, it is creating into that particular location, and you don't have a access to create anything into the data node. You are creating into a cluster. It's mean what I can say is, suppose I'm creating a folder slash inside of the slash user slash dvs or slash abc, something is there. Okay, inside of this particular one, this particular system, we are is creating a Ravi folder. That Ravi folder is accessible from all the data node that is created into one of the our main nodes. Understood? It is not like that. It is a one part of our data node. It's mean all the data nodes are clone of each other. It's mean whatever the data we are storing, that is actually like this.
I mean, you're telling like that folder will be created in all the clusters. I mean, in all the nodes.
All the, it is accessible from all the cluster. I'm just talking about the Hadoop cluster wise, right? So if I'm creating any of the folder, it is actually creating inside of our metadata of name node, and inside of it only it is storing. You are, see, when you are creating any of the folder, let's suppose a folder name is Ravi, and you are keeping any of the data ABC, that is actually storing into your cluster only, and the data node only knows with the help of the block level. That is a different thing. Understood? So when you are linking to any of the file, that file name is ravi.txt or ravi.csv or any file, that is actually you are communicating to the name node. Name node only deciding where need to be synced from you. Understood? You are not accessing this particular data directly. You want to access this data, it is accessing from the SDFS. Understood? So let's
Uh,
suppose if I'm just, yeah, go ahead.
yeah, you can go ahead. I mean, can you give me one
Yeah. So
example?
let's suppose I have a ravi.txt, which is right now in local system, and I just want to move this particular in SDFS, and the location of SDFS slash SDFS slash user slash Ravi. This is my folder. So inside of it, it will create a new file that is Ravi, or this file get moved, or you can say copy inside of it. So you are able to see this particular file. This file will not going to show in this manner. It won't show like this one block. It won't show you like this one, and there is another file inside of this particular one only. Okay, it won't show like this one. It will going to show you like Ravi only. You are only able to see this particular one. These kind of naming convention, it is actually only used for name node. Understood? The next thing, let's suppose I just want to copy this particular Ravi file, or maybe this inside of the Ravi folder, whatever the files are there, I just want to access it or get back into our system. So you will land up with only Ravi file back, ravi.txt. You cannot copy this block, this particular one. You cannot copy this one. You can only copy this particular file only. You cannot access this particular one. This is actually naming convention by the name node, and it is actually only readable by the name node.
Okay, I mean this belongs to the sum of the data node. This block what 113131. It is a some a block number. This one of the data node.
Yes, it is actually sequential wise. Let's suppose I will tell you. Let's suppose it very first block it came. It's a 1. The next block it will be 2. The next block it will be 3, and so on. That is unique among it. Let's suppose the block number 1 it is got deleted. Now the next block it is not like that. It is assigned to a block number 1. It is 4. Okay, now we are end up with something, and now we have this number of block. The next block will be in the sequence of this one only. Like this, and so on, it will get increased. Understood? So now the questions arise. You had noticed that in your system you had created this particular one block. Okay, you had created 41 and 42. It is a sequence. This is the one. But if immediately you had triggered another job, but the sequential number it got changed to 71 and 72, 73 like this. What about the rest of the blocks? So if you notice that there is a number of other clients also. This is a cluster, and it can be used with the number of users. Thousands of users are accessing this particular server at the same point of time. So those servers also are client. So they have their own machine and they are triggering that one. So that sequence will go to them. Understood? So this is actually just a naming convention. Whatever it is available, the next name will going to give to that particular block. So when we are triggering any of the jobs, we're not going to see that particular block convention. That will be decided by the name node. That all those things we're going to cover on tomorrow's session. So you will able to see this thing, how actually it is running. So we just need to trigger the command where we are triggering this Ravi file. That's it. And then I'll show you inside of the log how actually the name node is maintaining this particular one. Then it will be very easy for you people to understand what actually we discussed today. Clear, guys?
Okay, thanks.
Okay. And regarding your confirmations and all those things, okay, you people can communicate to them. And coming to the notes, okay, once I got a confirmation from the team, okay, they told me position.trainer 1409. You just send a message to me, DURGASOFT Hadoop morning session. 1 second, it is why actually it is not going. Give me a moment. Guys, my chat is not working. I'm just typing here itself. You just note it down. Zishan.trainer 1409@gmail.com. This is my mail ID. Just send a test message. A message will be DURGASOFT Hadoop morning. Sorry, spelling is mistaken. Okay, DURGASOFT. This one. Okay, DURGASOFT Hadoop morning. So this one just ping me or send a mail. Okay, then I will able to access your mails and I can share you the documents, whatever the documents I do have, which need to be provided. upon a confirmation from the DURGASOFT team. Okay, you just send a mail in this particular mail ID. Okay, clear everyone?
Yeah, yes, sir. Okay.
Okay, any other questions? Thiru, Ravi, Nikita?
No,
Sir,
sir.
for example, Ravi texted folder is 128 MB folder. For example, data black one is deleted. It's split into black 1, black 2, black 3. Okay, black one deleted. Then we'll go to another black this data.
Will not go for this particular one. That is actually maintained by the name node only. Automatically, they will maintain this replications. And
Okay, we
that
have
replication.
data node one, we have deleted that.
We cannot delete a single data node file. That is block 1, a block 2, a block 3. That we cannot delete it. We can delete the entire set of the data if we want.
Okay, okay.
If you want, you can delete the entire file. That is file name ABC or something. The entire replications also get deleted because the name node understands this is the command is given by the user. Okay, but we cannot delete a specific block. That we don't have a mechanism or something it is designed, because if you delete any of the block, it will be like rest of the block will be a junk file. Understood? So
Okay,
that
okay,
we cannot do.
okay, okay, sir. Thank you.
Okay, any question? Guys, clear? Ravi, Thiru, Nikita, any other questions?
No questions, thanks.
Okay. Okay, I think you people are clear. Okay, and still, if you have doubt, you can just note it on all the questions, and we can tackle tomorrow. Okay.
Oh, okay, sir. Okay.
Okay. Bye bye. Have a nice day. We'll see you tomorrow.